We are targeting here in our vision towards zero incidents. Hydrofluoric and nitric acid are quite risky. A good opportunity to have someone else walking into that area which is not a human. Let's talk around half an hour is gone just for setting your PPE up and also getting rid of it. And during that time, the robot can bring already valuable data to you.
I think predictive maintenance is the holy grail of the maintenance industry and professionals.
It allows us to create much more knowledge due to this data generation we have. And then elements like the robots are a big part of it. Hi, I'm Thorsten Piniek. I'm responsible for health and safety globally for Outokumpu, a Finnish stainless steel producer. And we are working since May 2023 with ANYbotics on autonomous inspections across 3 of our sites.
Hi Thorsten, thank you for having us here. Great to meet you again. To kick us off and start that discussion, maybe if you can introduce us to Outokumpu, what Outokumpu does, and tell us a little bit more about the product and industry.
Yeah, I'm Vice President for Health and Safety in the Outokumpu group. That's a responsibility for all the sites regarding health and safety, but also loss prevention and security. Outokumpu is a stainless steel manufacturer. We have a strong focus on sustainability, so we are working towards a world that lasts forever. So that is also in our slogan, and that is how we are driving also our activities. Beside of that, we have a strong focus here on health and safety, so that's our first priority, and we are targeting here in our vision towards zero incidents. So it is not just about the accidents, we also cover those near misses and so on, which could lead at the end to a more severe outcome.
Can you tell us a little bit more about the role, what it entails, what it means, what is safety to you, and what is safety to Outokumpu maybe?
I really like our safety principles because it is also directly starting what it means for me, because safety actually starts with each individual, and the safety starts with me. For us, it's also clear that we have safety before volume, so we prioritize that always first. We want to take no shortcuts, and at the end, also no repetition. So for us, the lessons learned when actually something happened is extremely important. So like we are looking deeper into that one, and that is also covering really my perspective, I have to say, on safety.
We've had some lengthy safety briefing this morning. We've had to take all our jewelry off. We are wearing the whole gear on ourselves to make sure that we are actually safe in the area where we are today. Can you maybe bring us a little bit closer to why safety is so important for Outokumpu?
Yeah, everybody counts for Outokumpu in the company. So we want to ensure that everyone who is coming to our sites, if that's an employee, if that's a visitor, is leaving in the same conditions. And for sure, also we want to be a role model there, so we don't distinguish there between visitors or own employees. Due to that, all the rules we have in place, we also follow then at the end.
And you've mentioned briefly just a second ago your vision, the long-term vision of Outokumpu in regards to safety. Can you elaborate a little bit more about what that means? What is that vision, and where you headed ultimately in your longer-term programs and projects that you're running here?
I would like to start a bit earlier there. Since 2016, for example, there we had incident frequencies, so which means how many recordable incidents you have per million working hours. We had around 8.7. And then we reduced that significantly by a really structured approach to 1.5 at the end of last year. And we are continuing this journey, because still there's a way to go to really ensure that everyone who was actually coming here is living in the same condition. So it is really purpose-driven and taking care about us, so everyone at Outokumpu. Let me further elaborate a bit on the different perspectives we have in that one. So everything starts at the end with some kind of risk assessment, and then we are driving from there certain initiatives. What is really reducing and eliminating that risk? Big topic is, for example, machinery guarding. A big topic is human behavior, and then it is also looking into technologies. How we can ensure that actually the potential is significantly reduced for people going, for example, in hazardous areas, and that is, I think, also quite nice bridge why we are using actually robots in our production facilities.
So you mentioned you are already at that goal of 0 accidents for quite some time.
Yeah.
Have you started from that level in this 2016 to reach that 0 accidents, or are you gradually increasing your ambition over time?
So this vision was also in the early step already announced, but we are talking about a vision, and we had in between for sure this mission step, which means we had always an unreachable target in between, because what we realized as well, targets have to be smart. So people have to relate to those targets, and we should have also the feeling of success at the end. And due to that, we have gradually reduced our target in a recordable frequency rates, and then also with the programs which we were running beside. I would like to mention one initiative, for example, we are doing here in Avestate, that is Act Safely with Pride and Care. It is all focused on the human behavior, how we interact with each other at the end, and how we lead by purpose, because we want to lead by the understanding of the people. Because that is a crucial step in health and safety, to make really the step change.
You've also laid out for us some of the key risks that you do have in this area here where we're today. And you have many more plants and many other various types of processes and production lines. What are some key risks and key risk areas that you are facing and seeing in your operations?
Key risks we have. So for example, we have still a lot of manual tasks in our facilities, which means people have to interact with machinery. We have for that in first of all guarding, but also instruction in place. So our material is quite sharp, for example, when it's especially cut. So we have to take care always about this cutting injuries. The next one is how we are maintaining our lines. Do we have the right risk assessment for those things in place? Are we actually using the right method to execute certain tasks? And then we have also risks due to our production environment. Let's take, for example, the acid treatment area where we are also actually in. We have to pickle our material, and why we have to pickle this? When we produce stainless steel, we have first of all the melt shop. You produce a slab, you are going through the hot rolling area, and then coming to the cold end. And you have to further to reduce several steps the thickness, and you have to recrystallize the material. When you recrystallize, you have to bring energy in form of heat. Due to that heat, you build up also scale. And to get rid of this really rigid scale, you need mechanical forces, but as well also acids to really clean the surface again. And this acid, hydrofluoric and nitric acid, for example, just to name two here, are also quite risky. So you have to know what you are doing there. And for example, those inspection tasks, we want to reduce step by step by direct monitoring of the line or using other equipment to monitor for it.
So you've mentioned pickling line, you've mentioned acid regeneration area. Are there other areas as well that are hazardous and that you're trying to optimize your workforce there?
Yeah, we have a quite unique setup in stainless steel industry, that we have our own mine in Kemi. When we get the pre-material from the mine into our production facility in Tornio, into the ferrochrome area, we have to crush the ore actually. And for sure in those areas there's also quite a good opportunity to have, for example, someone else walking into that area, which is not actually a human. Let's take here, for example, ANYbotics, the robot.
Very good initiative. So we've been collaborating now for over a year, ANYbotics and Outokumpu, with great collaboration. Thank you for that. Could you maybe tell us a little bit more about what are the steps that you have taken to isolate human workers from the dangers that we just discussed a second ago?
Let's start maybe a bit before we deployed the robots, first of all, we have really strict access rules to certain areas. So you have to be specially trained. What's the right PPE? What are the procedures to follow? And that is quite similar to the asset treatment. You need different kind of protection there, and also the instructions are different. So that was one of the first steps. Then also these accesses. Who is actually allowed to go there? It was just a limited amount of people to really ensure that people who are going there are then also trained sufficiently. What we are doing then beside is this automation step, which means what can be automated should be also a step-by-step automized. That is also in ensuring that we have less human interaction with the lines. And then I think the third element is then really looking into alternative technologies like robotics to further eliminate that people are going into those areas. And then what we have started there is we were looking really to the market. What are actually solutions for us? We looked into different robotics companies, also in drones, for example, and then we selected for us the most suitable solution, at least based on our knowledge so far. And then we had also a gradual approach how to deploy those robots.
What were some of the important selection criteria for you, or evaluation criteria?
So we want to have a robot which is made for industrial environment. So let's take a really simple example. For us, it is not so important what are the capabilities, how a robot actually moves. We want to ensure that a robot is sustainable in an industry environment, and that also the measurement devices which are mounted to the robot are sufficient for the jobs we have actually to do. So we need a good camera to have a proper overview. That is quite simple. You get that from a lot of other companies, but we wanted to have as well thermographic camera. We want to have also this ultrasonic microphone, for example, because leakages you could also easily detect via those microphones. But especially this, how rigid is a robot in an industry environment, that is the key driver.
What was the reaction of employees when you introduced robots to the operations?
In the beginning, we had a bit of doubts. How the robot is actually perceived. Do we see there somehow a distance that people also fear that they are replaced? And we made that really clear with our worker representatives that is exactly not the task. And when I think the storyline, how we communicated was quite strong. Because what we did beside is also we had there some kind of application phase to find names for the robot, and we have now unique names in all of our sites. So in Krefeld, for example, our employees chose the name Rosie. In Avesta we have the name Angie, and we just passed when we went here to that spot the dog box with the dog bone on top. I think that is quite nice because people like that we are investing in those technologies. And in Tornio the robot is called Jokery. So it is our joker at the end. When no one else is able to go, the Jokery will solve it at the end.
You have quite a lot of the dangerous areas here and various types of dangerous areas, as we already heard. Could you tell us a little bit more about what jobs ANYmal has taken over from your day-to-day tasks of your operators, of your human workers?
Yeah, it is about these inspections. We want to ensure that people are taking over the more important tasks. So what we do is we send, for example, the robot here in Avesta in the asset regeneration plant to different areas. We take then inspection points on that mission on the different levels here in that specific facility. We are sending that information then into the control room, interpret that sufficiently, and then taking measures based on deviation. So we are actually not interested in the values between the upper and lower control limit. We are looking more into trends and deviations. And that is somehow similar in all the sites with a different focus. In Krefeld, we are in the cellar of a pickling line, where we actually also use hydrofluoric and nitric acid, and we were expanding now recently in Krefeld also to go to one of our cold annealing and pickling lines, where we observe now inspection points at the annealing section. So you can imagine, you can go there, but it is also quite unpleasant environment because it is hot. We are freeing up time for our operators there. And in Tornio, it is the crushing area, so you have to follow a procedure to take the right PPE before you are going there, and you need a cleaning procedure. This takes already quite a long time. Let's talk around half an hour is gone just for setting your PPE up and also getting rid of it. And during that time, the robot can bring already valuable data to you at the end. So it is also a time effectiveness.
So you've already mentioned a little bit about the useful features of the robot. What are the inspection tasks that you're actually doing? So what type of equipment are you inspecting, and what is the actual inspection? If you can tell us a little bit more, a few examples as well.
So we have different kind of gauges, for example. So we use a camera to interpret what is actually the value shown there. For sure, there's also the opportunity to connect those to the automation system, but we don't have that everywhere. Second one is we are looking with the camera also for spills. For example, do we have somewhere a leakage? We interpret with the thermographic camera also conditions of bearings. For example, do we have somewhere a hotspot where we have to take an action? And with the ultrasonic microphone, we can also detect, for example, leakages from compressed air, as one example. What we take as a next step is we take a gas sensor to our cold annealing and pickling line, because we want to ensure also when we see there, for example, a gas leakage, that we can detect that as early as possible to gain their efficiency, and also ensure that we take as early as possible measures.
And can you share a little bit how, with the robot deployed in the hazardous areas, have you seen already improvement in the core metrics that you're tracking towards your vision, and how is that progressing towards achieving it?
First of all, we took the robot to come with our health and safety journey to the next level, which means what we are measuring at the moment is how much we have reduced the exposure of our employees. So, which means how many missions we were running, how long took those missions, and that is at the moment the success we measure. In addition, we are currently working also on a return on invest calculation based on our asset management program, which means what were actually the buy-in from our robot, inspecting deviations at our lines and taking then preventive measures before actually a line broke down. So what were the preventive measures we took based on the robot? So that is the next journey where we are looking into. But that takes still a bit of time to have there also certain maturity. And one reason is also that we moved now to our couple 3 in Krefeld, because that is one of the bottlenecks we have there. And we can ensure that we are looking there more into that.
I think predictive maintenance is the holy grail of the maintenance industry and professionals. So what I'm hearing is that you're actually looking into enabling a little bit better data feed into that program that you're running.
That is quite well matching with the program we are already running. So we are adding also a lot of measurement devices to crucial equipment. But beside of that, there are still plenty of opportunities. And then this flexibility of the robot is quite nice, because we can take it wherever we want, more or less, to be reachable from the perspective.
Is there any advice that you have for companies or organizations that are looking into deploying robotic solutions like ANYmals?
For sure, I have always this health and safety background. So I would really recommend to start really with risk assessment, and then being really technology open, which means what could be, for example, suitable solutions. I would just like to mention for working in height, drones, for example, to take inspection is a great opportunity. What is the right technology to work then on the shop floor? Then a second really important element is how to onboard your employees, being really transparent what you want to achieve actually, and then doing their really proper analysis. What could lead to success at the end? What are the right resources to use? And then also challenge the companies you are working with together. What are already the learnings to somehow have their aspiring to be really successful, and then also being demanding to those companies to grow in some kind of partnership. Because I'm convinced when you have this open communication, your partners will be also quite open, because you want to grow together. They want to have a successful product, and at the end you want to have a success in the deployment and implementation in your sites. So it is really interconnected. And then I think the last element is also, when it is something really new, you have to be effective in communication. Communicating those small steps, so not using it that just in your own bubble. You have to be really active in your organization, what you have actually achieved, what are the next step, because then you get easily also the buy-in, because it is not just the health and safety department, it is not just maintenance and asset management, it is the whole organization which is working there together.
What are some long-term benefits that you see from a general automation and robotization of the industry going forward?
I see from automation in general big opportunities that we can use much more the knowledge of our people, less the manual tasks, because I think it is much more important that we know from our people how to run those lines, but these actually manual tasks should be step by step reduced, because there quite often the risky part is into those. And then it allows us also to create much more knowledge due to this data generation we have actually beside of that. And then elements like the robots are a big part of it.
Thank you for your time today, and it's great that we were able to meet here and discuss your robotics aspirations and the robotic journey. So thank you so much for that, and all the best for the future.
Thanks, Tom. It was a pleasure to talk to you.
As always, Thorsten, thank you.